Hello, this is Mr. Wyrick, and today we'll be addressing lesson 2.2, the second one from chapter 2, which is all about logic, trying to come to logical conclusions, trying to use what you have in front of you to come to another conclusion. This kind of goes off of the inductive reasoning, and it has a lot to do with statements. So you're going to need to make sure you look up those highlighted words in the beginning of this lesson. Make sure you get those defined, get them down into your notes. There's also some stuff in there that we'll go over here in a bit that you'll need to make sure you take some stuff down. First off, anytime you make a statement, the statement has a truth value. It is either true or false. Today is Sunday. It's not Sunday today, so that would be a false statement. Today is a day ending in Y. That one's always a true statement. When you are dealing with this kind of stuff, those statements are usually represented by a lowercase q or a lowercase p, and they'll make sometimes two statements. One of them will be p, one of them will be represented by q, so that they can say multiple things about those. Now, a negation of the statement is just a little kind of tilde mark, the one that's up above the 1 in front of that p or in front of that q, that says the opposite of this statement. So today is not a day ending in Y, and it makes it a false statement from a true statement, or a true statement from a false statement. Now, sometimes you'll be dealing with a compound statement where they put together more than one. So the sky is blue could be a statement, and today is Christmas could be another statement. If you have and with that compound statement, then the sky is blue and today is Christmas, that one would actually end up being false. That one's called a conjunction. It's another one that you're going to have to define. That one would be false, okay? Because both halves of it have to be true if you use the word and, okay? Today is Friday and I'm drinking liquid nitrogen. Well, even if it is Friday, I'm not going to drink liquid nitrogen, so that's not a true statement. Now, and is sometimes represented by this little top hat symbol, so it'll be like Q and P, not an A, just that little arrow up, that little caret. So Q and P means we need both of them to be true. The disjunction of that statement, when you use or, would be the Q and then like a V and a P, meaning only one of them needs to be true for the statement to be true. So I have two daughters and the desk is, I have two daughters or the desk is brown. That would be a true statement, even though the part about me having two daughters is false, because the desk is brown. If we have this or, if we have a disjunction compound statement, only half of it needs to be true to count it. We have a truth table. You'll need to look at what a truth table is in your book, but basically it gives you the statement, the other statement, the negation of the statement, and maybe a compound statement, a conjunction, or a disjunction, and you just fill out that little grid as to which ones are true, which ones are false. It gives you an opportunity to answer a whole bunch of things about it all at once. It'll really help you if you're doing conjunctions and disjunctions to say them out loud. If you say it out loud, middle of class, you can whisper it to yourself in the middle of a test, whatever. But when you say some of those things out loud, you could really hear it and you can say, okay, wait, is the sky really green? So you don't just automatically get in a rut of just marking true, marking false. The next thing that you're going to need to make sure you understand about this is going to be a Venn diagram. Venn diagrams have to do with sets and whether something is inclusive, exclusive, or multi-part. You've all seen a Venn diagram, probably in English, okay? So if I went and got like 40 students from the school and I started classifying them based on whether they are in geometry and whether or not they are female, okay? If I got some out of, say, Mr. Cardiel's class or some other class, just some sampling in the hallway, and I had like a 50 over here, and I had 30 here, and I had another 25 or so here. That would mean that there are 25 students that I saw that were in geometry that were not female. There were 50 students that I saw that were female that were not in geometry. It's outside of that overlap. But where the overlap exists, both conditions are true. So 30 students were both in geometry and females. Make sure you're looking through this stuff. Make sure you're paying attention to this one. Just as a quick check, this lesson is for Thursday, the 17th. So I would like you to come in Thursday, the 17th, and I would like you to have a statement, a logic statement written as either a P or a Q. Come into class, and we will use that in the warm-up. We'll see you then.